explain about the direct comparison test and the limit comparison test, or the DCT and the LCT, which are two tests for determining whether a series converges or diverges by comparing it with a known series. Let's get into it. We'll start with the DCT. Its definition says that if you have two non-negative series called A and B, and B is greater or equal to A for all terms, then A converges if B converges and B diverges if A diverges. Let's do some examples. Let's call the series that we want to know whether it converges or diverges as A. Then we pick another series that is already known and call that B. We know that B diverges because of the p-series test. Now, we are going to spread out both series by writing out their terms. If you look and compare the terms, you can see that all the terms of A are larger than B. Therefore, we can say that A is greater than B, and we know that B diverges, or that it approaches infinity. Something greater than an infinite value is also infinite, so A diverges as well. The same is true for the opposite case. Let's say that A is now equal to this. Then let's pick a new B, which we know converges because of the p-series test. If you spread out both terms, you can see that A is less than B. B is finite, and anything less than a finite value is also finite. Therefore, we know that A converges. However, this test will not work if the series is larger than a series that converges, or if a series is smaller than a series that diverges. You need to use another known series or another test. So let's move on to the LCT. Its definition says that if you have two non-negative series called A and B, and C is the limit of A over V as n approaches infinity, and if C is finite and positive, then the series will both converge or diverge. Let's do an example. Now, the DCT only works when all the terms are greater or less than a known series, so we can't do that easily here. Let's just use the LCT for this one. So let's begin by picking a similar series for B, just like what you did in the DCT. But this time, we're going to divide one series over the other. In this case, I will divide B over A. Then, we will get this fraction's limit as x approaches infinity. After some calculations, we get 1. This shows that the series are growing at an infinite equal rate, and since we know B converges, A should also converge. However, this test will not work if the limit is less than or equal to 0. So you'll have to try again or use another test. This test might take longer than the DCT, but it can determine for a wider range of series. So a tip for selecting the known series to compare it with the unknown series is that if you don't know what to choose, then you should just start with a series that has just a term with the highest degree, as the other terms will get dominated as the series approaches infinity. Some examples of this is that, let's say we have a series like this here, then we want to pick this, the square root of x cubed, because that is the term with the highest degree. Or if you have something like this, then we want to pick this, or like 3 factorial, because that that grows faster than the other ones. So that's it. You learned both the direct comparison test and the limit comparison test. I hope you gained something from this video. Thank you for watching.